Now we're moving on to setting data boundaries. AI tools introduce a new way to access data, and it's one that creates new risk. The key principle is simple. AI should not create new access to data. It should inherit the controls you already have in place in your financial applications, such as your ERP, such as your treasury management system, and your data systems that support those tools. But here's the issue. Many AI tools don't enforce this automatically, so you can't assume that just because a user has limited access to the underlying system, that the AI will respect those same boundaries. You need to think of AI as a completely new entry point into your financial data. And there are three main risks that I want you to watch out for. The first being overexposure. And this is where the AI has access to more data than the user should actually see. Second, prompt leakage. This is where sensitive information is stored in the model logs or ultimately visible to the tool administrators. And third, training risk. This is where your data is actually used to improve the external models, meaning that the results can be used elsewhere in the future, and that's not something that you want with your confidential company data. So the rule is simple. If you don't know exactly who can see the data, don't upload it. This mindset alone is going to prevent the majority of any real-world issues that you'll run into when working with AI. So before you use any tool, ask yourself these three critical questions. Does the tool inherit your existing permissions? Is your data used to train public models? And who can actually see the prompt logs internally? Because the prompts themselves may contain things like MNPI or deal information that should not be made available to the broader employees of a company. If you don't know the answers to these questions, you are taking on risk. Now, in terms of evaluating these tools, not all answers are equal. If your data is not used for training, permissions are respected, and logs are restricted, that's a great sign. But if data may be used to improve models or admins can see everything, that's a huge red flag. If you do see any red flags, don't upload your sensitive financial data. Now we're going to go ahead and put this into practice with a practical exercise. What we're going to do here is imagine that you're preparing a daily global cash position across 15 bank accounts to feed into an AI tool to generate a rapid end-of-week liquidity forecast. What I want you to do is access this file that's going to be made available to you through the course, look for hidden risks, look for structural problems with the file, and any exposed sensitive data. What I'm going to recommend doing at this point is hitting the pause button so you can try this exercise for yourself. Go ahead and download that Excel workbook in this module and jump in. And when you resume, we're going to cover the 3 fatal flaws in the file. Okay, you should have paused and you should now be ready to resume and review the solution. And it really shouldn't have taken you that long. First, there was this idea of data toxicity. Column D in the file contains actual wire routing numbers and full account numbers for the concentration of accounts, instead of masking them with, a unique identifier such as bank name, account type, and a unique number. Next, there was a structural flaw you needed to find. Merged cells grouping European entities together. Now, this one was color-coded and it stood out pretty well, but nonetheless, if you don't unmerge that cell, the AI is going to assume and attribute the total euro balance to the first entity in the region and ruin your forecast. And lastly, there was another data toxicity risk. Did you find it? Did you see that there was actually a hidden tab labeled Project Phoenix, and it detailed cash that was segregated for an upcoming highly confidential acquisition? So hopefully you found that one, given what we looked at earlier in the course. So I hope that you found all 3 flaws. It's okay if you didn't, but keep these potential flaws top of mind next time that you're preparing any data file to load and use within an AI model. Now we're going to recap what we've learned in Module 1. In Module 1, we have explored how to manage our data before working with AI. We looked at spotting hidden risks. That's where we talked about things like data toxicity. We then looked at cleaning our spreadsheets and structuring the data for the AI machine. We spent some time talking about setting data boundaries and the importance of access controls, and that we shouldn't be giving more access to the data than the access that is granted through the underlying system where the data came from. And then we looked at a quick practical exercise, the Global Cache Positioning Audit. And you saw there everything that we had put into practice in terms of making sure that your files are clean, simple to read, and do not contain confidential information. Now, in the next module, we're going to shift from preparing our data to actually working with AI in real time. You'll learn how to trace AI outputs back to their source. Because in finance, there's no such thing as mystery math. We need to understand where it comes from. We'll also cover how to identify outdated or misaligned data before it leads to bad decisions, which is a very common failure point with AI. And importantly, you'll learn how to assess the different types of AI outputs, so you know when to trust them and when you need to dig a little deeper. And then we're going to finish Module 2 with a hands-on exercise, just like we did in Module 1. But this exercise, we're going to focus on a flawed FX hedging recommendation and trace exactly where it all went wrong. Congratulations, you have successfully completed Module 1. Thank you. I will see you in the next module.